Good morning, dear students. Today we'll see the problems on Cauchy's root test. In the previous class, we have seen what is Cauchy's root test, when it is going to be convergent, divergent, and when that test going to be failed. And we have seen one of the example also. Now in today's class, we'll see the next example. The example is discuss the convergence of summation n from 1 to infinity 1 plus 1 upon n whole raised to n square. So here also they have given the nth form already. So solution. So given is the nth form. So this is what here un is equal to 1 plus 1 upon n raised to n square. This is our nth form. Now I will apply the Cauchy's root test for this. So we know that in Cauchy's root test un raised to 1 by n form is nothing but Cauchy's, means for the given you apply 1 raised to n. So what happens, just we'll see, 1 plus 1 by n raised to n square whole raised to 1 upon n. Okay, so this we have kept as it is. So taking 1 raised to n on both sides. So now we'll simplify this. So on simplification, what happens, we'll see here, 1 plus 1 by n into this will apply exponent formula. So this will become n square upon n. So which is nothing but 1 plus 1 by n raised to, among this 1 n cancels, raised to n left here. So now, so by Cauchy's root test, what says Cauchy's root test? That is limit of un raised to n 1 by n as n tends to infinity is equal to, will apply the limit here, it will be limit n tends to infinity. This is our u raised to 1 upon un raised to 1 upon n. So we'll apply. So it will become 1 plus 1 upon n raised to n. Again, as per the note, we know that what here, one of the result already I have shown you, limit 1 plus 1 upon n raised to n as n tends to infinity is nothing but e. So the result will apply. So directly I can say that this is e, because limit as n tends to infinity 1 plus 1 upon n raised to n is equal to what here, e. And already I had told this e is nothing but 2.7, which is greater than 1. If it is greater than 1, what happens? If it is greater than 1, it is what here, divergent. So therefore I can say that the series is divergence by Cauchy's root test. Next example is discuss the convergence of summation n from 1 to infinity n plus 1 raised to n x raised to n divided by n raised to n plus 1. Now this is already nth form. So I can say that given is un is equal to n plus 1 raised to n into x raised to n divided by n raised to n plus 1. This is given n. So to test the convergence by using Cauchy's, we know that we needed un raised to 1 upon n we needed. So if you take power n raised to n, what happens here? So it will be n plus 1 raised to n whole raised to 1 upon n into x raised to n raised to 1 upon n divided by n raised to n plus 1 raised to 1 upon n. So we have to take a power 1 raised to power 1 upon n on both the side. So we'll simplify this. So on simplification, this n and n get cancels. We are going to left with what here? N plus 1. So here this n and n is going to cancel. So x remains. Here what happens here? You first will simplify this. N raised to n plus 1 can be written as n raised to n into n raised to 1 upon n, which is nothing but n plus 1 into x divided by, we'll apply the power this. So what happened? N raised to n raised to 1 upon n into n raised to 1 upon n. So this n and n cancels. So this cancels here, this n cancels. So what happens? N plus 1 into x divided by, so what left here? N cancels, n left, n into n raised to 1 upon n left. Or we can again we can simplify here, but we'll take the limit on both sides. So on taking limit on both sides, so what happens? Limit un raised to 1 upon n as n tends to infinity is equal to limit as n tends to infinity. This will become what here? N plus 1 into x divided by n into n raised to 1 upon n. So here always we'll take n common, because infinity plus 1 is infinity. To bring the infinite result, will always take n common. So among the numerator I will take n common. So n tends to infinity as it is. So in the numerator if I take n common, what left here? N into 1 plus 1 upon n into x as it is. So n into n raised to 1 upon n as it is. N cancels. So left part is limit as n tends to infinity. So what left here? Here 1 plus 1 upon n divided by n raised to 1 upon n into x we left here. Now I want to separate the limit for both the numerator and denominator. Just see here, limit n tends to infinity for the numerator, 1 plus 1 by n into x divided by limit as n tends to infinity n into 1 upon n, because we know a few of the standard results, so that to apply that we need to work out. So denominator, limit as n raised to 1 upon n as n tends to infinity is always 1. You just refer the note, or as well as we have seen one of the example based on this. Now limit as n tends to infinity, you apply n as infinity. So 1 upon infinity is 0, and 1 plus 0 is what we left. I will write here 1 plus 0 into x as it is. So therefore limit un raised to 1 upon n as n tends to infinity, we have left with what here? X, because you see the 1 plus 0 is 1, 1 into x is x, x upon 1 is x. So therefore we got the result what here? X. But we don't know what value of this x takes here. So as we know that if x is greater than 1, it is convergent. If it is less than 1, if it is greater than 1, divergent. If less than 1, it is convergent. Or we can say that we got a general result. So thus the Cauchy's root test is that is summation of un is equal to, so I can say that it is convergent if this x is less than 1, it is divergent if x is greater than 1, and test fails if x is equal to 1. So in this way, because we don't know what value of x takes, so we need to predict it. If it is less than 1, so convergent; if it is greater than 1, divergent; and if it becomes 1, so test will going to be fail. So these are the one of the important kind of examples, so you need to remember here. So we'll see the few more examples in the next class.